Hey guys, welcome back to another chemistry video. So today we're looking at energetics. This question: consider the following reaction: N2 plus 3H2 yields 2NH3. And it says using the average bond enthalpy values, calculate the standard enthalpy change for this reaction. So the formula to get the enthalpy using the bond enthalpy values is delta H of the reaction equals the sum of the bond enthalpies of the reactants minus the sum of the bond enthalpy of the products. And then to find those bond enthalpies and which bonds we're using, we just draw the molecules. So it's N bonded to N, H single bonded to H, and for NH3 it's N with 3 H bonds on it. And so the sum of the bond enthalpy of the reactants is just the N triple bonded to the N, and 3 of the H single bonded to H. And then for the products, we have 2 NH3s, and each one has 3 NH bonds, so it's 6 of N single bonded to H. And then just plugging in the values from table 10 in the booklet, we get 944 kilojoules per mole plus 3 times 436 kilojoules per mole minus 6 times 388 kilojoules per mole. And then just calculating that, you get an answer of negative 76 kilojoules per mole. Next part, the absolute entropy values S at 300 Kelvin for N2, H2, and NH3 are 193, 131, and 192 joules per Kelvin per mole. Calculate delta S for the reaction and explain the sign of delta S. So the formula for the delta S of a reaction is the sum of the S values of each of the products minus the S values of the reactants. And just to remind yourself of the formula, N2 plus 3H2 yields 2NH3. So the sum of the products is 2 times 192. The reactants is 3 times 131 joules per Kelvin per mole. And then the H2 is the 193 joules per Kelvin per mole. And then if you work all that out, you get negative 202 joules per Kelvin per mole. And the question says, explain the sign of S. The sign is negative, and what that means is that through the reaction, there's a decrease in entropy. And to explain that decrease in entropy, we can look at the moles of gaseous molecules before and after the reaction. This is a G. And so you notice that after the reaction there's 2 moles of gaseous molecules, and before there's 4 moles. And so that means that there's a decreased entropy. And that makes sense because from our calculations we got that there's a decrease in entropy. Next part, calculate delta G for the reaction at 300 Kelvin. So the formula for delta G is delta G equals delta H minus T delta S. And we have delta H as negative 76 kilojoules per mole. T they give us as 300 Kelvin. And we just calculate delta S at negative 202 joules per Kelvin per mole. And making sure we get the units right, we need to change this negative 202 into kilojoules instead of joules. And so what you do is you just divide by 1,000. And then working that out, we get negative 172 kilojoules per mole as our delta G value. Last part. If the ammonia was produced as a liquid and not as a gas, state and explain the effect this would have on the value of delta H for the reaction. So as we know, delta H has to do with how much energy you produce through the reaction. And so what they're saying is that instead of having the 2NH3 as a gas, it is produced as a liquid. And so this is called condensation. And as we know, condensation is an exothermic process. So for this reaction here, we associate a delta H value that is less than 0. And that would mean that the total enthalpy of the whole reaction that we're talking about would decrease because we release more energy by producing it as a liquid. And so the effect is that delta H0 would be more negative.